Welcome to Brain Vision.
In this problem, we have a baseball that's thrown straight upward, and we're told that the drag force is proportional to v squared. And so, in terms of g, what is the y component of the ball's acceleration when the ball's speed is half its terminal speed when it's moving up and when it's moving down? So the first thing we need to do is figure out what its terminal speed is. And that would be when the acceleration is 0. And that terminal speed is, so if we do a force balance here, we need obviously Fd to be opposing g, or opposing the weight. So that's going to be a plus in this case. So we wind up with W equals A, which is my proportionality constant, times V terminal squared. So the terminal velocity is simply the square root of the weight divided by the proportionality constant here. So half of that is half of that. So is this expression. So now when the ball is coming down, okay, when the ball is coming down, A is going to be, this is going to be positive. So we have minus W plus AV squared equals MA. Now we take this value for V, plug that into here, and so that becomes, the A's cancel out and we get 1/4 W. So we get minus 3/4 mg equals ma, so A equals minus 3/4 g. So it's coming down slower than it would if there was no drag, as you would expect. Now, when it's going up, this force is going to be this way, so we have a minus sign here. So this is going to be, minus. So we have minus W minus AV squared equals MA. Plugging in this value for V, we get minus W minus 1/4 W, which it winds up being minus 5/4 mg, so A equals minus 5/4 g. So when it's going up, it's actually being accelerated back down by more than gravity, because the drag force is also resisting its motion.